All right, moving on with inequalities, you can see what we're doing here for this one. This is the next section, 5.4. We're looking at compound inequalities. Okay, now compound, if you were thinking of, compound words, or if you just think of the word compound, it means two. So now, if we have a compound inequality, we're going to solve two inequalities for each problem. Now, there's two different types. You can see I have the keywords and and or. On this video, I'm just going to focus on if we have or. Now, if I said to you, you have to do your math homework or do your English homework, you could do either one. We're not sure which one you're going to do. So when we have this as solutions, we're going to include both. Okay, it's also called union. Now let's see what this looks like when we look at a compound inequality. The first one's actually already solved for you. We have x is less than 1. Let's put this in blue. Or we have x is greater than 2. We know how to graph these. I'm going to put, let's say, the origin here, 0, and then let's put 1, and then 2. Now, if I have this less than 1, I'm going to have an open circle, and I shade to the left. So everywhere to the left. Now, if I have this, x is greater than 2, it's still an open circle, but now I shade to the right. So now you can see you have two different solutions. Okay, a solution could be anywhere to the left of 1, or it could be anywhere to the left of 2. You're not specifying it. So that's kind of what the or means. So you're including both these shaded regions in the solution. You could also take this and you could put this in interval notation. So let's just do this, because we did introduce this with solving normal inequalities. I'll just put interval notation. Now this is going to be a little bit more complex. Now this part right here, this goes to negative infinity, so I'm going to put negative infinity, and then it stops right here at this 1. And I'm going to put parentheses because the 1's not shaded. Then I'm going to put u. What that u means is union. Union means you include everything. So I'm also going to include this part. Now this is going to be parentheses 2, and this goes all the way to the right here, so it's to infinity. Okay? So we kind of did two things. We graphed the compound inequality, and then we also put it in the interval notation. Okay, let's look at the next one. Let's look at number 2. Number 2, just like number 1, let's make it a little bit bigger here. There we go. Just like number 1, it's already solved for us, so let's just graph it first. I always like graphing it first because it gives us that visual. All right, we have x is less than or equal to 0. So at the origin, it's equal to it, so I fill it in. It's less than or equal to it, so I go to the left. Right, I have all the negatives here, negative 1, negative 2, and that goes to negative infinity. Then it says, or x could be greater than 5. I'm just going to say this is 5 right here. Okay, it's not underlined, so that means it's an open circle. If it's greater than 5, I shade everything to the right. So you kind of see how these or inequalities, most cases, not all cases, okay, there could be a special case which we'll go over in class, but most cases when you shade, it goes to the left forever and the other one goes to the right. So it's kind of disjointed. So if I put this in interval notation, okay, I always go left to right. Again, this goes to the left forever, so it's negative infinity. And then if I follow it left to right, it stops right here at the 0. Now since this 0 right here, see how I'm filling it in? Since that's filled in, I put brackets. Then I put union. Then it starts up again here at 5. But I'm going to have parentheses at 5 because 5 is not filled in. Goes to the right forever, so then it's infinity. Okay, and again, that u means union. Okay, let's just do one more. Let's do number 3. Now, number 3, we're actually going to do some math. Number 3, the x isn't by itself. I'm going to solve for each of these inequalities. Okay, I'm going to solve for this one first. The x minus 4 is less than or equal to 3. A very, very simple inequality. If I add 4 to each, just like that, I get x by itself, and x is less than or equal to 7. Okay, then I'll put or. Then when I do the second one, let's put this in red. Well, if it's 2x is greater than 18, I know I just have to divide by 2. That cancels. Divide by 2. So 18 divided by 2 is 9. So if x is greater than 9. Okay, and let's graph this. So now I know how to graph it. All right, so if I graph this, let's see here. I have 7, 8, 9, let's put 10, let's put another one, 6. So this I want to graph. If x is less than or equal to 7, I know it's a closed circle. If it's less than or equal, I shade everything to the left. Okay, this one I'll put in red. If x is greater than 9, well, it's an open circle on 9. Since it's greater than, I shade everything to the right. And then if I put this in interval notation, okay, this part right here again is negative infinity to this 7, but there's brackets. I'll put union. Let's continue with the color theme here. It picks up again at 9. 9's not included, so it's parentheses. It goes forever to the right, so it goes to infinity. All right, so when graphing these compound inequalities, you're going to have, most cases, you're going to have two regions that are shaded, and it could be, you know, this x is less than or equal to 7, or it could be x is greater than 9. We say this is U for union because we include everything for both solution sets.